from Jadavpur University in 2009. He is working as an executive dean and institute distinguished senior chair professor, Techno India, NJR Institute of Technology. He has more than 210 publications in reputed journals, 11 books, and 37 field Indian patents in his credit. He has supervised 10 PhD candidates successfully on various research assignments. He was visited Waseda University, Japan in 2012, University of Mauritius, Nanyang Technology University, Singapore, Lincoln University College, Malaysia in 2018, National University of Singapore 2019, and Asian Institute of Technology, Bangkok, Thailand in 2019, and ISC Delhi in 2019. He is Fellow of Royal Society of Arts London, IET UK, IET ISRD UK, IAER London, AEI, CETI, and many more. In 2017, he had been evaluated to senior member of IEEE USA. So it's my pleasure to introduce Professor Prasun Chakrabarti sir, and I hand over for the next session to the Professor Prasun Chakrabarti sir.
Okay, thank you, Dr. Vivek.
Thank you, sir.
See, today's lecture is based on our collaborative research work in Techno India Innovative Lab. That means the iCube Labs, which is actually one of the most research-oriented labs in Rajasthan. So there we used to do the industrial projects also, and also the academic and research projects. So today's lecture, before I start today's lecture, I am thankful to all my research team members of this particular lab, and right from principal investigator Professor Aaditya, Professor Yogendra and his team. So let's start. Today's topic is basically, you see, computational techniques. Now, it is such a technique that can be applied in any particular domain. So now it is up to us that how we want to apply that. So actually, now let me share my slide. Yes. So now thing is that this computational technique, that means here we actually apply this particular technique on the basis of the computers. That means the computers, they actually analyze and solve the scientific and your engineering problems. Now, I have actually segregated this particular lecture into certain domains. First of all, it is basically computational architecture and arts. So let's see how we can apply there. Now, visualization, I am sure that all of you know that what do you mean by visualization. Now, when we tell regarding the visualization, it comes that what might be the nature of the 3D model visualization phenomena from the architect's perspective. Now, when we are technological person, so when we actually want to apply technology in visualization, that means there is a term that means the neural style transfer. So it is basically what? So it is basically optimized technique that is actually used to take two images. That means one is basically a content image and another one is the style reference image. Then when we blend these two images, so the output image that will be actually in the form of painted form. So another thing is that the 3D visualization of buildings, that also is very much applicable, not only from an architectural skill point of view, but actually you have to draw the 2D drawings, and then how you can actually visualize that 3D based on its 2D drawings. That is also plays a very, very significant role. Second thing is that the digital fabrication. So you see, in this case, the current research indicates that how you actually develop and integrate innovative digital technologies. That means what? That means here you first have to transform the building industry on the basis of building industry 4.0. So I know that all of we are actually aware of the term 3D printer. So that 3D printer comes under this particular category. Another thing is that here the building information modeling, that means this BIM that uses basically CAD. Now, one thing I'm telling you that whenever we apply these computational techniques to any particular field, first we have to ask ourselves that what is the objective? Because ultimately we have to see that whatever result we are going to get, whether it is as per our expectation or not. So now BIM is the 3D modeling. Now it actually works to increase the collaboration between the designers, the subcontractors. In case of computational architecture, I'm telling you. Now BIM software that is used almost everywhere. Another thing is that the generative parametric design. Here in generative design, there is a huge scope of artificial intelligence. Now, actually, what is that? That is basically iterative process. So there, what we do, we actually use the advanced algorithms. Since this, I don't know whether the participants are belong to not only from CS, from other backgrounds. So algorithms we have to use in order to get the optimum solution. So what we have to do? First, the designer, he actually needs to set your constants and goals, and then we have to provide the metrics, and from the metrics we rank the results. So when the software, in case of generative design, it delivers the first set of results, then it uses the evaluation metrics to rank them. Now what happens when we rank them? Then obviously we get the poor solutions, so you reject that, and after that you obviously create a set of solution based on the features of the highest score. So this actually is basically the approach. Another one, that in parametric design, what happens, it actually helps you to create the design based on the input of parameters. Now, when I'm telling that input of parameters, that basically means what? That means this allows the designers to make changes to the project in real time. And these input parameters are very much important, because the feature selection is a very important aspect in this particular perspective. Another thing is that the audio visual processing. So as you can understand, the term itself reflects that perception. So one is basically the perception, that means the light, sound, now the decibels, your power, everything. Here we have actually, we can apply the multimedia theory. And in this particular case, when it is actually related to your computational arts, so here your basically the interactive cinema and also the interactive media and electroacoustic music comes into picture. As in the terms of your audiovisual signals, obviously the Fourier series, the discrete DFT, the FFT wavelengths we can use. Now, one important thing is that in this particular case, there is a research challenge that how we can remove the jitter, that is the noise within the sound. So for that reason, you may apply the processing, that means the structured video audio processing and the max NSP jitter elimination problem. Thing is that we actually don't understand that what is the meaning of that information art. That means whenever it is the arts side, we sometimes we feel that there is no application of technology in that particular field, but it is not like that. Thing is that when you actually accumulate certain data, then as per the conceptual means art, electronic art, or whatever you tell that suppose it is a new media art, then what you will do, that means first the realization of information art, that not necessarily that interdisciplinary, it has actually multidisciplinary approaches, including the visual, audio, data analysis, performance, and others. So the physical and virtual installations involving your informatism often provide the human computer your interaction. Another thing is that computational astrophysics. So you see, in this particular field, there is immense opportunity of your computational techniques. That basically means what? See, again, I'm telling that when we actually model something, first you ask yourself that what is the objective of that? That means in this case, the most important thing is what? The compressibility on the structure of the turbulence. Because first thing is that the modeling of turbulent, your compressible flow. That means in this case, what happens, that the modeling issues, that means the compressibility effect is investigated in the context of engineering models. And those models are actually needed for complex flow computations, specifically the KE model. Now, whenever in terms of your astrophysics, this flow of the basically this plays a very important role, because when we are actually model the flows, those are basically on the basis of your strong streamline curvature. And from that, if there is any inhomogeneity arises, then you have to actually eliminate that on the basis of your modeling purpose, so that ultimately you get a supersonic flow effect. Another thing is that the stellar atmosphere. So how we can do that? Here, see, this electromagnetic radiation, when we want to analyze, that means we can directly analyze that only on the region where the radiation becomes the one we register, maybe via our telescope also. So in this case, modeling is basically done on the basis of, suppose you can apply the opacity distribution function also, you can apply the Monte Carlo simulation also in this particular computational astrophysics. Another aspect is hydrodynamics. So in this case, what will happen? The hydrodynamics codes, those are actually used for any astrophysical phenomena observed. Now there is certain hindrance also, as you know that there is a trade-off, that in every case there is a certain means that the pros and cons of any particular your effect. So you see that the basically when this particular radiation codes are being actually used on the basis of growing number of astrophysics problems, right from your energy flow and accordingly, such as the gas pressure of a temperature that can be increased, then how we can handle that. So it is up to that. Now the planetary dynamics, you see, first of all, you have to first in this particular perspective, first we have to that detect or characterize the stability of multiple planet systems. Second thing is basically here you can apply the secular dynamics also. Here you can apply the chaos theory also. Here you can apply the secular dynamics also. And obviously that is the main thing, that the solar system dynamics also is very important in this particular perspective. One important another aspect is that the in-body simulation. So in this case, what will happen? That basically means when it is a in-body simulation, from astrological point of view, you see it is basically a dynamical system of particles. So in this case, the particles, what happens under the influence of physical forces such as gravity. So what happens, these in-body simulations, these are widely used tools in astrophysics. That means here, right from investigating your dynamics of periodic systems like your Earth, Moon, Sun system, and from there, how you have to find the cosmology, that means in physical cosmology also, how the galaxy filaments, how the galaxy halos, and how you want to study the dynamic evolution of star clusters. That means the movement of that particular stars and their mathematical modeling, and then forecasting that at this particular instant of time, what will be the position of that particular object. Accordingly, it will actually reflect in the result of the forecasting in astrophysics. Now, computational biology is also another very important aspect where you can apply computational techniques. That means in computational biology, there are algorithms also where you can see. Out of that, you see that in this particular case, this computational biology, the major problems that relate to the molecular or evolutionary biology, and focus on analyzing and comparing what the genetic material of organisms. Now here the bioinformatics plays a very pivotal role, because here we actually need to see the modeling, we have to make the prediction, we have to see the gene sequencing, we have to predict the ATG sequence, so accordingly we can do. So what happens that in this particular case, the DNA, RNA and proteins that are actually responsible for storing and utilizing of genetic material, that actually in the form of a string. Now when it is a string formation, that means it allows what, that means the algorithm techniques, that is how those strings are stored, and accordingly based on certain matching algorithms, you have to find out that what are the common features, how we can extract the common features of a particular individual, and how we correlate that with the features of the other individual. So accordingly a particular your mapping table is constructed. Second is that the biomedical analytics, you see, it is basically a science of developing and applying computable algorithms. Now, when I'm telling that computable algorithms, that means it is based on basically mathematics, operation research, statistics, and computer science. So all the fields, those are actually related to this particular biomedical activity. There, what happens? That means first you extract properties from biological and medical data. And then what happens? Once you extract, then you analyze. And then what are the research findings? See, in any research, there are certain findings. That means what is the inference? What we want to do. That means in this case, what we want to achieve. So in this case, we want to basically achieve what? That the basic clinical and the translational research in the form of medical. That means it has a social impact. So what is the goal? Goal is basically what? That it improves actually the patient outcome. So basically, biomedical analytics is basically a primary research based work. And application of biomedical, it includes what? The study of biofluid, also the study of tissue data using statistical and network analysis. Why? Because in order to discover and understand the change in the molecular patterns, because here what happens, when a particular pattern is stored, then that particular, there are various patterns. Now, each individual has basically a distinct pattern. Now, when it is a distinct pattern, that basically means what? That means those features are actually dedicated for that. Now, there may be some common features also. So those common features can be stored in a particular database. Now, if there is any another feature, which is basically a random feature or basically a stochastic feature, then if that particular feature arrives, then we have to first find out that it belongs to which particular individual or not. There you can actually apply the approximation theory. Sequence analysis is another form. There what happens, that it's a very, very important aspect of bioinformatics. Why? Because they're actually the computational analysis of DNA, RNA sequence, peptide sequence. That is very means important. There what happens, the biological function, structural equations, and the evolutionary algorithms we have to carry out. That means the sequence analysis. So in this particular case, we need to follow certain analytical strategies. Now, depending on that, you see, when we actually do this particular sequence, then what happens? That means there should be some classes. That means either the sequence of this particular class, if it is genomic, whether it is the proteomic or any other classes. That means what? In this case, we can actually apply the machine learning classifiers. Once we apply the machine learning classifiers, then for each particular pattern, we can find out the sensitivity analysis, specificity, and the accuracy rate. And then we can find that which sequence analysis actually delivers the best accuracy rate. Accordingly, we can do. One important aspect also is the molecular modeling. That means what? When I tell that the molecular modeling, that means here all the methods, both theoretical as well as computational. That means those things have to be blended. And then we used to make the model, that means the models are used in the fields of computational chemistry or basically the drug design. So here the calculations that we can carry out, and here that is basically on in the basis of here your Monte Carlo molecular modeling software. That is extremely important. We can use that particular software. Now comes computational chemistry. Now thing is that as chemistry, so normally what happens, that it's a normal phenomena that chemistry, if someone actually studies, he's scared of mathematics. But I'm sorry that there is immense application of mathematics in chemistry. That basically means, first of all, in computational chemistry, first the quantum chemistry for the molecules and the materials. That means in this case, what will happen? The potential, your energy surfaces, the periodic DFT, all these, the wavelet transforms, those can be actually applied. Apart from that, the non-periodic calculations for the condensed matter, your matter, suppose the queuing models, those things you can actually apply in order to calculate and then interpret the properties of the molecules. Second thing is that the computational chemistry for the biological macromolecules. Now, here you see there is an immense scope of research direction in this particular field. Because what happens in this particular topic, you see the chemistry, biology, and mathematics, computer science, all the fields, those are actually responsible. That means it is basically a sort of your interdisciplinary research. So here what happens, first of all, we can describe the key principles. That means that common techniques that are actually used for simulation and macromolecules. Then what happens? We can actually perform some basic simulations. Means then your Monte Carlo simulations and analyze the output to describe the biomolecular function. Now, when we want to actually describe the biomolecular function, from there, what happens? The output patterns are generated. So on the basis of output patterns, you can actually find out the classes that this particular pattern, this particular biological macromolecule, this has these certain properties. Maybe some has anti-leishmanian properties, some has anti-cancer properties. So accordingly, a technique will be developed. So we can apply then multi-scale models. We can apply. We can also critically assess and select the appropriate computational tool. Because when a biochemical problem is given, then first you have to analyze that which particular actually tool you have to generate. Second thing is that the statistical thermodynamics. So this actually thing is that basically one is basically the theoretical aspect and one is the simulation prospect. So that basically means what? That it discusses basically the physical interpretation and justify the use of different superpositions and calculate the thermodynamic properties in the model systems. Another thing is that you actually analyze and apply the partition function theory on your fluids. Second thing, you can evaluate and also analyze the usefulness and limitation in both models and simulation models. Now, computational earth science. In earth science also, this we can apply the computation techniques. One is basically what we all know, the term atmospheric modeling. That means in this case, what happens? What we have to do, the researching the micro scale, macro scale, and the scale of atmospheric phenomena. So how we can actually do your electromagnetic pulse signatures. Now this we actually simulate. The objective is what? To characterize lightning and security issues. Another thing is that the subsurface flow. So here what happens, we have to find out the chemical interactions with respect to time, with respect to environment, and movement through our natural resources like your soil, rock, water. And then what you have to do, you have to develop a particular model. Once you develop the model, then you apply that model. So when you apply the model, what is the objective? As I always tell, ask yourself that it is not like that forcefully you have to apply computational technique. So when you ask yourself that why I am doing this, that basically means that why I develop, why I apply the model. It may be what? To predict your flow and transport of your multi-phase fluids. Another thing is that improving geothermal and oil gas extraction. Another thing basically what? That nuclear non-proliferation and global security. It's a very important aspect. In this particular case, the research directions, one is basically the climate impact relation, that is very, very much important. And I think the environmental management, they are actually the weather forecasting, the rainfall estimation. There you can actually apply your neural modeling also, that how we can apply which computation technique we can actually use. On the basis of that, we can understand what is your effective forecasting in case of environmental management. Now, in case of your computational linguistics, it's actually basically what? That means it is basically interdisciplinary field. So here the statistical rule-based modeling. So what happens in case of computational linguistics, we have to find out the various aspects of NLP. That basically means that what is basically the text summation, what is the news corpus, what are basically the latest trends, how you have to match the words, how to match the grouping of the sentences. So here you basically can apply the non-probabilistic parsing. You can apply the language modeling and nebulous. We can also apply the machine translation. Information extraction obviously is very important in this particular field. Unsupervised language discovery, that is also there. So in this way we can do that. So basically it is basically a scientific and engineering discipline. And as I told you that it actually the future of computational linguistics. That means how that's your text translation and the speech recognition also, how you have to do that on the basis of this. So here you can actually develop certain algorithms and you have to test your algorithm with respect to your existing algorithms. Now basically, another thing is basically what? The computational management science. So when I'm telling the computational management science, that indicates that in this case, one is basically the computational economics. So as I we all know that from simple, I am not going into much technical details. Just one thing I'm telling you, there is one aspect in microeconomics that is the demand supply equilibrium. So there, what happens, you have to find out a mathematical, you can find out a mathematical model that what is the actually the market demand for a particular commodity, and then accordingly you can actually measure the elasticities. Elasticity is basically once you measure that, then you can find out that what is actually your consumer demand theory. So these things you can apply there, and accordingly you can see that what is the what is the production level, what is your cost of production, and here also you can apply the Cobb-Douglas model also for the production function. As a production function you can do that. So the computational techniques play a huge role in microeconomic theory. Statistical finance, obviously it is there because it is the application of econophysics to financial markets. So here basically you have to find out a positivistic framework. That means from that you have to find that yes, a future gain forecasting, that here also certain models you can develop, that whether it is exponential your economic your decay model, that means then you have to analyze that why there is a you have to analyze that why there is a degrade in the profit margin of a particular organization or not. That can be the time series modeling also. Another thing is that you can, in this particular your computational management science, you can apply certain optimized algorithms also. Maybe those can be of deterministic, also stochastic, robust. This your optimization models you can do. Forecasting, yes, forecasting is a very important thing. That basically means what? It is basically when I tell that forecasting, that means you forecast, fine. Now as I told you, ask yourself that why you forecast, what is the significance of forecasting? Once I forecast, then what I will achieve? That means forecasting basically what? It is basically decision making tool. Now, many businessmen, they use this particular tool just to help in what? The budgeting, planning, and obviously the estimation of future growth. It plays a very significant role. So in simple terms, it is basically a technique to predict the future outcome based on past event and the management insight. So here you can actually apply the time series model, you can apply the econometric model, you can apply the judgmental forecasting model, you can apply the Delphi method. There are so many methods. So please try to apply those things, and you find that what are the changes, and then accordingly you can, depending on the need of the application, you can understand, no, for this particular application, this particular method is the optimum method. Now, decision making, it I already mentioned in case of that it is in modern management, obviously it is there because here you can actually apply many managerial decisions, and based on certain models. That means the rational model is there, incremental model is there, non-rational models are there. So you apply these particular models, and then you find the result of each particular model, and you first analyze that which one actually suits well for your particular business here. Computational techniques play a very pivotal role in computational mathematics. That basically means, you see, first of all, your computational topology. So here it is basically intersection of basically what? Your mathematics and computer. So this is related to what? The study of efficient algorithms. This is for the topological problems, that is especially that arise in the areas of computing. That basically means what? Here the computational topology combine classical mathematical techniques also, from combinatorial, from geometric, algebraic topology, with more recent algorithmic tools, right from your data structure design. And yes, one thing I'm telling you, in this case, the computational geometry comes under this particular area. So those who want to pursue research in computational geometry, they can think of this particular sort. Algorithmic algebraic geometry. So it's a very important thing. Well, one thing is that see, by virtue of this sort of lectures, as I told you, that when you actually talk among yourselves or other researchers, you can learn many things from them. Just a simple example I'm giving you, that recently I was thinking about some business forecasting model, and then here there's another colleague, Professor Jitendra Simali. He actually once told me, sir, we can actually apply the algebra, linear algebra in this particular case. So from that point of view, I'm telling you that your algorithmic geometry that actually plays a very important role, right from your counting roots, right from your polynomial parameterization of curves, right from your rational parameterization of surfaces. It actually plays a very pivotal role. Cryptology, it's very, all of you know that what is the thing, and basically that it is basically based on the fundamental mathematics, that means the cryptology number theory and application of your formula and algorithms. So in this case, what happens, this cryptanalysis concepts that you have to find out, that means here mainly your complexity analysis, and nowadays there is very computational activation functions for the automatic variability concept of key. That means what, the key will actually change from session to session. Now you can use that on the basis of certain function. That function has to be a reversible function. Simple example I give you, that if you apply the XOR operation, that means the XOR operation, then what happens, that particular, suppose a particular plain text XOR your key, that becomes the ciphertext. So when you apply the same your XOR function, accordingly you can decrypt and you get the year. So what happens, the activation function that should have the reversible property, and the last thing is that the number theory. So in this case, what happened, we actually apply higher arithmetic. That means basically what, see, this is basically a branch of pure mathematics, and it is actually a study of integers and integer valued functions. So here the computational point of view is what, that basically means first you study your prime numbers as well as the properties of objects made out of the integers, that means the rational numbers, and then you generalize the integers. So in this case, often means you have to find out the analytical objects also, that how you actually encode the properties of integers also, and how we can study real numbers in relation to rational numbers. Now it's a very interesting thing, that is the computational mind theory. See, we are individuals, and our actually expression, our actually mood, it actually depends from time to time. So when I'm telling that like that, that means first of all, as I say that human mind, that is in this particular case, all the branches are actually related, far right from your psychology, right from computer science, right from philosophy. So how, if you see, that means it is basically studies on the mind. And then what happens, the cognitive neuroscience, how you can apply here, that is what are the local behaviorism and the type identity. That basically means what, that means the mental state. That means in this case, what happens, the beliefs, that means the sensations, the emotions, that means how, according to logical behaviorism, what happens, that mental states, as you know, that means those are basically variable. That means from a particular timing instant to another one, your mental states, they actually vary. So in this particular manner, what happens, you actually do the changes. So mental changes are states that actually play the appropriate roles in systems functional organization. And thing is that, you see, in this case, I'm telling, suppose in a mind theory, I'm telling that here there are certain events that are biased. That simple example I'm telling you, that suppose a particular, today the mood of a particular person, it is not up to the mark. That means in that case, if someone actually grants a particular request, then even though it is justified, then at the same instant it is not granted. So, but this particular scenario that may change on any other day when the mood of the particular person is good, and then when his subordinate used to ask that, okay, sir, can I leave today early office? Then accordingly the mind can change. So it is basically depending on your timing instant to timing instant. That means in this case, what happens, that it is we based on the mood change, we have to do that. Another thing is that the computational music science, it is very important. That means in this case, what happens, the music theory. So have you ever thought that how the music theory you can make mathematical modeling? That means in this case, first task is what, you analyze the music. That is first you describe and explain them. Then what, study, characterize, and you reconstruct the musical object. And then what happens, you compose that. So when you compose that, so accordingly you can get certain patterns, and from those patterns will be very much important for the analysis purpose. Another thing is the computer music. See, here in computer music, the application of computing technology is very much important. Why? Because in music composition, It actually helps what? The human composers create new music. You see, a simple thing I'm telling you, that suppose you have bought today a new means suppose your synthesizer, then obviously first of all you want to see that yes, if I can compose my own music. So it is like that. That means how independently you can create music. So here also, from the background seeing, it is basically the algorithmic composition of programs. So here what includes it may includes the theory and application of new and existing computer software technologies, basic aspects of music such as sound synthesis, digital signal processing obviously plays a very important role here. The sound design, it's very important here, how you can actually calculate the sonic diffusion. Okay, so then here another thing is that the acoustics, how it is actually related to that. So all these are extremely important aspects of computer music. Another thing in terms of your computational aspect, you see the systematic musicology. Now, it is basically interdisciplinary science. That is, here the aim is what? To explore the foundations of music from different points of view. From what? From acoustics point of view, from psychology point of view, from physiologist point of view, from music theory point of view. So what happens? The most important means sub-disciplines of this word, that basically means the philosophy of music, the music acoustics, the cognitive music. So these things you can apply here. And you also means here that you can actually apply the signal processing also. You can apply the music ethnology and research trends also, like your embodied your music cognition model. The cognition model also plays a very important role in this particular case. Next is music information retrieval. So what is that? That is, in this case, it is also another study that the process, the system, the knowledge representation. Now, why it is required? It is required for retrieving the information from your music. Simple thing I'm telling you, suppose a music is in symbolic format. So in audio format, suppose it is MP3. In vector format, suppose it is scan score. Now, music your information retrieval, it has certain advantages. That means what? It takes advantage of technologies, knowledge derived from your signal processing, machine learning, music cognition, human computer interaction. So you see, many researches are going on in this particular field, right from concerning the automation of access to music information through the use of digital computers. Another thing is that there are certain projects going on. The latest research trends in foreign universities, lot of work is going on computational musicology. So first of all, the corpus studies. So those are basically what that particular case basically means. These are the very common type of project in computational musicology. That means now a corpus basically uses the software. I don't know how many are aware of that. It's from simple layman's point of view, I'm telling you, so that everyone can understand that a corpus study, it actually uses the software to analyze the statistical pattern in a large collection. Now, once you have done this, that means it actually reflects basically the descriptive statistics for musical data. Now you can use, because now you have to make the experiments in order to find out certain permutation combination, and you have to generate the pattern. So that is your objective. As I told you, that whenever you want to compute something, you have to apply computation technique. First you ask yourself, what is the goal? Why I'm doing this? Similar thing is there, that why I'm doing this here. That means one, you have got that your descriptive statistics, right? Now what you'll do, just like text-based corpus studies, you actually make your studies, you involve the Markov models here. Now, once you get the Markov models, then what? You can make the probability analysis for progression in time, and then you have to find out that what is the pattern of this particular corpus. Another thing in case of computational musicology, that is the modeling purpose. That means in this case, what happens? The computational musicologists, they have been employing more advanced statistical methods. Purpose is to uncover the underlying functions and patterns that actually contribute to the surface musical features and pieces in their corpora. So here, obviously, you can, I don't know how many of you are aware of the term Bayesian statistics. Here we can apply there. We can apply the hidden Markov model here, just to find out the chordal functions in a chord progression. And then accordingly, the computational musicology tuning you have to do. Another thing is the music encoding also you can do, because it is very important aspect, music encoding in case of computational analysis. So here what happens, the musical data that can be encoded digitally in a way that makes sense both for the music and for the analysis to be performed. So here that is basically a task for any musical artifact. Music interval, your information interval, as I already told you, it is also very much important in this particular case. Now, another thing is that the oceanography. Now, how we can use the modeling? That means in case you see, basically in case of here also the chemistry, the importance of chemistry plays a very important role, because how you process the modeling in case of marine chemistry. Even we can use also satellites also to transmit data from ships to show laboratories for processing also. We can use the accurate simulation of underwater sound, and once you get the underwater sound, then you can actually simulate and you can predict that what types of sounds it may arise. So in case of your underwater domain. Now, computational pharmacology. See, in this particular case, artificial intelligence has a pivotal role. It plays a very, very important role. That means in this case, how many people are aware of the term AI-based drug design? Lots of work is going on in the entire world of AI-based drug design. In this particular case, what happens? First of all, it is basically the effect of genomic data. So, when I'm telling that, that means in this case, you can actually make the modeling, you can make the data analytics in order to find out the link between the genotypes and disease, and then you screen the drug data. Another thing is that the development of accurate drug. When your development of accurate drug, so you see this data-driven drug development resources and methodologies there that you have to do. That means here, large your scale biological experiments you have to carry out. You have to find out your clinical trials from the medical reports from participants. Obviously, when I'm telling the medical records, there are certain norms in various countries. You have to take permission. So without revealing the identity of a particular patient, we can do that, obviously. Understand? So it's because our aim is basically the modeling. So irrespective of the identity of the patient, that is not required. Only I want to consider the data, say. So basically the enrichment of biological and clinical context also you can do, and this particular case that means the identification of basically what your drugs for specific diseases. Now, simple example I'm giving you. Now we in this particular scenario, we are actually undergoing to the COVID era. Fine. So if you see at the TV news that in news channel, we see that yes, initially the doctors, they are claiming that the drugs given for malaria, those are very much effective there for the COVID. That means why? That here what happens, first of all, why this happens? That means since the COVID is basically unknown as stochastic disease, whose patterns are basically of unsupervised manner. So the symptoms, if those match with our known diseases, then what happens, the doctors, they also make the trial and error. They actually give the malaria, and then they have to see that whether it is done or not. Similar thing is, if someone claims that yes, I have discovered your vaccine for COVID, then the trial phase has to be there. So once the trial phase is over, then only you can claim that yes, the successful discovery of that particular thing. Drug discovery. See, in this case, again, I'm telling you, the biotechnology, the pharmacy, the AI, that means the computer science, that is all are involved. In this case, what happens? It is the process. That means drugs are discovered and designed. That means you see here, what you have to do. That means a new approach has to understand that how disease and infection are controlled at the molecular and physiological level. Now, as I told you, that when means you do something, then first you have to ask yourself why. That means why it is there. That means in order to find out what the target is, what that the specific outcome, that in this particular case, if you design this particular drug, then in which cases that particular drug is actually useful, what are the patterns of the basically symptoms, what are the treatments, and what is the your rate of rate that how this particular drug, it is whether effective or not. That means the utilization rate also you have to see. That means the recovery rate also you have to calculate. So accordingly, the clinical trials will be there, and then not only one clinical trial, you have to carry out several clinical trials, and then only if you find that this particular drug is optimum, then only you can think that yes, it will actually end the drug development. The clinical trial is over, so now the drug is ready. One important thing is that the QSR modeling. You see, in this case, actually you can apply the regression or the classification models, and those can be used in the chemical and biological sciences and engineering. So here there is obviously there is a relationship between the chemical structures and the biological activity in a data set of chemicals. Next, you can apply the computational techniques in physics also. First of all, in population theory. Simple thing I'm telling you, that when it is basically a population theory, that means the behavior of a network, while the nodes, those are basically links are removed, that means it is basically phase transition. That means here what happens, there are certain branch processes comes into picture. Simple example I'm giving you. Suppose you are drinking water, fine. Now you intentionally put the water on the surface, on a flat surface. I'm telling you, it is not. I'm telling that it is a flat surface. That means the smooth surface. So have you ever noticed that when you actually put that particular water in the floor, that basically means the what is actually the flow sequence of that particular water? You see, it is basically automatic branching, and so accordingly the population theory. So here those branching processes, that is basically it cannot be predicted. So that is one of the idea. Another thing is that the mathematical perturbation theory. Yes, it is basically what that is here. The computational techniques are what, just to find out an approximate solution to a particular problem. So two things is that if you break these, that means one is basically the solvable, another one is the perturbation. That means here it means what you can do, suppose the non-linear contributions, just like to the equation of motion, interaction between particles, those things you can apply that how for the interactions between the particles, the terms of perturbation series, that means how you can do that, these things. Another thing is that the agent based modeling. Here also the computational modeling you can apply. That means it is basically the modeling of dynamical systems of interactive agents. So here what happens, your agents have the internal states. Now these can be represented by your discrete or continuous variables. So accordingly, this agent based modeling, there is a ample scope of your computational technique. Numerical relativity also, as we all know regarding Einstein's field equations using the supercomputer also. So that is also another thing. Another thing is the statistical physics. That means in the Monte Carlo your simulation in statistical physics, that actually plays a very, very important role here. It deals with the computer simulation of many body systems in condensed matter physics. So this thing is there. Another thing is that the computational neuroscience. So you see, when I'm taking the computational neuroscience, that means here basically what? That means you have to read the brain. It is actually related to the brain science. Then how the electrical and chemical signals, those are actually used in brain. And then how you have to process the information mathematical introduction to neural coding and dynamics. So here you can apply the convolution theory. You can apply your probabilistic theory, obviously stochastic models, and you can actually develop the models for the synaptic transmission. So here there is basically open problem I'm giving. That means the human thought process quantification. That means how you can model the thought disorders. So this is not readily available anywhere. So those who are interested, they can actually pursue this means work. That means depending on the, suppose someone is suffering from schizophrenia, someone is suffering from amnesia, someone is suffering from memory loss. That means whether it is short-term memory loss or whether it is a long-term memory loss. So how we can actually do that? Even in case of psychiatric patients also, first you have to find out what are the thought disorders. Okay, and then you have to model that whether those thought disorders, is there any mathematical equation that fits that. That is thing. We can also study on the basis of the patients suffer from actual brain cancer. So there what happens, the thought process of a particular individual, that varies from a particular time instant to another time instant. So whether we can predict any particular pattern or not, so accordingly you can do. So there is ample scope of means research in this particular field. So with this, thank you. So now I'll be very happy if you all please.
Thank you very much, sir.
Questions
Thank
or
you very
not?
much, sir. So if any participants have any query, they can share it in the
Yogendra
question
sir,
answer
I want
box.
to, is my, now there is no slide, na?
Yes, sir.
Okay.
Yeah, yes, sir. So we are just waiting for some questions if there are any
Yes, yes,
queries
please ask questions.
in this
See,
question.
I request all the
Question answer.
participants, please ask the questions, because see, this is open research problem, because the questions that you will means ask, that is not the only question. There may be others also. So you can actually apply this computational technique in any particular field. Only thing is that we have to first identify the problem, we have to analyze the problem, and then you can do the modeling. That is not a problem. But ultimately what happens, you have to find out that what is the optimum situation. Understand? So
I have a query, sir.
yes, yes, tell me, tell
Yes, sir.
me.
So for my research topic, like the analysis of the breast cancer, how can we implement this computational techniques? Right now, we are just computing it for prediction, like or diagnosis on that given database. So what techniques we can use further to enhance the results?
Fine. So, see, in case of, first of all, you have to techniques, not I'm telling, that means, see, whenever there is any means your feature selection you do, that means that feature selection, what is the purpose? That means how you can improve the your accuracy and how you can actually decrease the training time. So that should be the objective. So basically you can do that on the basis of various things. That means first you have to reduce the overfitting. That means if there is any less or redundant data, then how you have to do that on the basis of noise. Then how you can improve your accuracy. That means in this case you have to be sure that there is less misleading data, and then you have to reduce the training time. That is one thing. Then another thing is that you use the cross validation correctly. That means it is basically what, see, a very common difference is that when you estimate the cross validation, it is the result common problem that appears that in any test data or that whether something is going wrong or not. That is when in this particular case what happens, one term I'm telling, that is snooping, SNOOPING, and snooping. Another thing is that the incorrect sampling. So we have to make sure. Another thing is that you have to choose the correct score metric. That means the right score metric. That means how we have to optimize an error metric your method on the basis of any learning algorithm. And then you have to find out that what is the accuracy. Another thing is that you know that you have to find out, you have to go for the best hyperparameters. Next thing is that when you actually make the model, then you have to test that. So how you test that particular model? That means you see that machine learning, you see it involves building many more problems, fine, many models, and create many different predictions. So ultimately the principle is very simple. You estimate variation, that is basically random. That means by average of many different models, you have to find out the threshold value. So that is also another perspective.
Thank you very much, sir. I guess Aditya sir, is there any question from the participants?
Participants, please ask the questions, because it is not ask the question to test me, because this is such a field so that you all can apply. So if you ask anything from any perspective, then at least we all can, even if I fail to answer, because this is such a field that is an open research problem. It is not that it is written in the textbook. That's why. Yeah. Another thing I'm telling you, one thing due to lack of time I'm telling, means I missed that even you see you can apply the reinforcement learning also in various stages. Okay, so there what happens, especially the deep reinforcement learning. Okay, that also you can do. That means there you have to find out the brute force attack also, how the value function you can estimate. Monte Carlo methods also you can apply in any particular reinforcement technique. That means those things you can do that.
Okay, sir, we have a question
Okay,
from a participant. Okay.
Yes, tell me.
I do have
one
a
part.
question. Let we have a take question from Lalit Yagni first.
Yes, Lalit sir, tell me.
Yeah, hi.
Hi.
Sorry, I because I was somewhere else at the university, so I joined it halfway through.
Yes,
But I found some of the discussion of you were leading into quite interesting, and always is a question to me, application of machine learning for this neuroscience, particularly when you're talking about anything that gives you an area of prediction towards all these diseases of Alzheimer's, memory loss, etc. So my two questions or related questions are, since you are working in this area, that is this one, is that related to getting the data, because whatever sensor data captured through the brain, whatever they insert, is that, first of all, efficacy point of view, is that the right data? Do we have enough knowledge that are we capturing the right data? So that's the first question, because whatever mathematical modeling we are doing on top of that. And then question is that even if we do, let's say, do modeling on that, do we have any feedback loop to see whether whatever prediction are we doing, are we able to relate it? So in a way, this is kind of interrelated questions, that you do the model and then you are able to do some predictions. Then is that prediction found to be correct? So anything you can throw light on what's happening in that field, because I don't get a clarity in that area with whatever I read. So what are your thoughts on that?
My thought is that, see, there are many neuroscience databases. First of all, regarding the first question, that data set I'm telling you, that the Alzheimer's disease data set that is already available, that means your neuroimaging initiative. Another thing is that the big brain, that is also another one, but it is not open source. You have to actually contact to the medical hospitals. Yes, one thing I'm telling you, really, we are actually also suffering from that particular thing, that our research is going on. We have to find out, because very few we have got data from the medical perspective. Okay, so that is one thing. Another thing I'm telling, there is a website, that means the braindevelopment.com. That means when I first actually have a patent on this thing, there I actually collected from that particular data set. That means there the MRI data sets are there, and from there you actually structure the MRI images and atlases. So from braindevelopment.org, you have to talk to the they are the concerned person, and you can actually take the data set. Now, in case of another thing is that they are readily available, the cancer data sets also, that is also readily available there. So the data set will not be any problem as such, it is there. So only thing is that you have to apply that with that data set, which particular features we have to actually collect, and then how you can apply in your research. Open neuro is also another open neuro is also another your macroscopic A. There what happens, the raw data is there, and then from that that is also related to your brain imaging. So from that, first you have to eliminate the noise. So after processing of that particular data set, then only you can tune that, and then you can train the model. That is the first question regarding the data set. And second thing, that as you told that whether this particular technique, whether it is effective or not. So Lalit sir, I'm telling you that the accuracy of any particular thing, that we cannot claim that it is actually means appropriate. That means it is we cannot claim to a particular conclusion that no, we cannot do this. Only thing is that we are there is some threshold value. That's a simple thing I'm telling. Suppose a particular model is there, now the accuracy, suppose from the literature review we have seen that it is 82%, then we can actually try so that we can actually get up to it. That means then only we can tell that our proposed algorithm or our proposed design is actually in the same tune with whatever existing or what other researchers they have actually done that.
Yeah, thank you. Yeah, that answers the question. Yeah, but my concern, or not concern, but a question.
Yes, I understood your.
I mean, in the rest of the cancers, etc., at least the data we are capturing
Yes,
at least is because the field is quite old, so it is clear that these are the contributory factors. But in case of brain collecting that data, so my I mean, if I put it without causing any questioning, but even are we really capturing the right data which really have an impact?
Yes,
or
sir.
is it because brain is very hard to think of that we are capturing the right data,
and it is a very, very tough task. It is not so easy.
Correct, yeah. Okay, thank you, that answers my question.
Thank you, sir.
I mean, this is with accuracy of the collecting the right data set for the problem statement. We are going to solution. I mean, we are going to find the solution for the machine learning model. I have the same questions as Lalit sir have already asked, but I have another question with computational music techniques in artificial intelligence, sir.
Which one?
Computational music techniques in AI.
Yes. Tell me.
One of your slides had mentioned that a computational music techniques is a trend in AI. I mean, now research is focused on the use of artificial intelligence in the, complication of musical composition, performance, or produce digital sound processing, and sales and composition of music. I mean, many AI-based, even AR Rahman, create a program and create an application to produce music and used for teaching and creating music, right? So, so in certain way, sir, what is the disadvantage of these computational music techniques in AI, where we may, get a shortfall with the data collection and all kind of things?
First thing I'm telling you, see, when the term artificial intelligence is there, so it is basically you have to we actually accept that particular model only when we tell it is accurate. Understand? Now, just simple thing I'm telling you. Today we are talking about AI, but when in the initial times, when the great music composers, they actually composed on their own. There was no AI technique. Understand? So thing is that one is basically that thing. That means whether, because main important thing, two things. One is basically what your music streaming. In music streaming, there is the delay that I told you that in one audiovisual case, that is a jitter. So that is the most important thing. So if how you eliminate the noise, how we can actually eliminate the delay, that is the most important thing. And so that is one of the most important challenge. And another thing is that in this case, when you actually make the permutation and combination of any particular your node, suppose a particular tune is there, then whether it will fit or not, that means if it is as a simple thing I'm telling you. Suppose there is a data set, suppose there are instruments sets I1 I2 in. Now you have composed a particular tune. Now if that tune is any item of any one of those initial sets that already supervised set, then it is fine. But if it is a stochastic tune, that means a new tune, then only you have to approximate, and then you have to find out to which particular tune it actually fits. Understand? So the fitting problem also is a very challenge.
So it's basically hit and try kind of techniques.
Yes.
So as a beginner researcher in this field, how we should proceed with the collection of data? Suppose I want to produce one music from AR Rahman collection songs. Let me curate all songs from the YouTube from the with the copyrights, and I want to produce a mashup song from the AR Rahman. So in that way, what is the accurate method to curate the data and use those data to produce a model?
See here, first of all, one thing is that you have to you please study the computational proximity measure. There is a term, computational proximity measure. So that is, you can note down, otherwise I can mention in the chat. So when you do that, then what is happened, that is you have to survey of pattern recognition for various computational music. Now what happens here also you can apply deep learning also in the domain of computational musicology. So one thing is regarding that. Another thing is that you can mention that in any case of this particular music transcription, there is an automatic music transcription. Automatic music transcription means the automatically the scaling, accordingly the adjustment you will get in the form of a string. So that particular also acts as a pattern. So the pattern matching here comes into picture. So pattern recognition, pattern matching, these things you see. Another thing you study, the principal component analysis.
Okay. Okay. Thank you, sir. Thank
Thank
you
you,
very much. We have another question from the audience. Siddharth Bansal, we would like to ask you that how to apply in military. Siddharth, if you can, how to apply in military. Siddharth, if you can elaborate the question.
Yes, please unmute him.
Let me do for Siddharth. Siddharth, now you can talk if you want to ask question directly to Prasun sir.
हिंदी में बोल सकता हूँ
आराम से हिंदी में बोलो ना बात
अरे हिंदी में बोलो, कोई दिक्कत नहीं, बोलो बोलो।
हम सभी को हिंदी समझ में आता है।
जैसे मिलिट्री में ये कितनी बार देखते हैं कि हम ये हमारा डेटा हैक हो जाता है, तो ऐसा कुछ मॉडल बना सकते हैं जिससे कि ये कम हो सके।
अच्छा, see, ये question not only due to your military form, okay? Hello.
Yes sir.
Okay, so one in that means your system that should be secured, fine?
Yes sir.
Hello, I'm getting you or not?
Yes sir.
So how you have to address that particular cases? That means in means military situations. Simple thing. I'm telling you that somewhere you have seen that they have actually attacked the particular means the main server. So how it is there? So in this cyber warfare also, what we can do, that there is a debate actually, that how you can actually make your military application in order to respond to a cyber attack and these things. Okay, so we can actually, there are many threats, understand, that you have to first study, and then what happens, you have to taken care of denial of service attack, understand. In your military service, a very important is the electrical power grid. You can note down electrical power grid, because what happens, the electrical power grid is very much susceptible to your cyber warfare. Understand? Hello?
Yes sir.
Okay?
Okay sir, thank you.
Also, I would like to pitch in this question, Siddharth. Try to understand this is all about mathematics. If you develop one algorithm or program, there is always a way to get back into that program. कुछ अगर formula बनाया है तो उस formula को crack करने का भी एक formula बनता है. So it's called basically it's called in decryption and encryption methods. तो जब टेक्नोलॉजी इवॉल्व होती जाएगी, उसकी इंक्रिप्शन मेथड बढ़ती जाएगी, सिक्योरिटी बढ़ती जाएगी, और उसी के साथ में उसके डिक्रिप्शन मेथड्स भी बढ़ते रहेंगे. तो इट्स ऑलवेज अबाउट हाउ यू सिक्योर योर डेटा. तो डे बाय डे आपकी सिक्योरिटी बढ़ती रहेगी और उस डे बाय डे उसकी इंक्रिप्शंस और डिक्रिप्शंस मेथड बढ़ते रहेंगे. तो इट्स अ रेगुलर प्रोसेस. वी नीड टू बी स्टे अलर्ट. दैट्स ऑल व्हाट आई वांट टू से.
Am I still unmuted or
yes,
am I muted?
Yes, sir. We can.
Yes,
I just want, can I add a little bit to this?
Yes,
sir,
yes,
why
sure.
not, sir?
You are welcome, Lalit sir.
Because right now, last 1 to 2 months, it may be worth whoever asked the question to remain tuned, but there is a major attack on whole Australia by China, cyber warfare.
Yes,
and
yes.
there is a massive investment government of Australia is making in this field. Billions of dollars are right now getting spent, and it's a multifaceted approach among many things, even including teaching entire workforce. They call it Soldier On initiative. IBM has taken to train everybody on cyber counter attack or protecting. Well, Australia won't say counter attack, but anybody interested in that field right now, there is a lot. If you just Google it, you will find many initiatives, and as Aaditya and Prasun explained, that this is not a one thread, end-to-end aspect of cyber warfare. But right now, the entire country felt that it was under siege at a government level, at a defense level. So it's a case study. But so if somebody is interested, you should be at least spending a couple of hours every day on what's going on there.
Yes, I fully agree with Lalit sir and Aditya. It's very good. Okay, is there any other question?
Yogendra, is there any question, or we can sum up?
Yeah, I guess there are no more questions.
Thank you, participants. Thank you so much. Thank you so much.
Thank you
It's
so much.
really, thank you so much once again.
Thank you so much, sir. So on behalf of IEEE Computer Society Student Branch, Techno India NJR, and the organizing committee. I would like to thank you very much, sir, that you have given time from your busy schedule and enlighten us with such a great lecture. Thank you very much, sir.
Thank you.
Thank
Thank
you.
you. Thank you.
Thank you
Thank
so
you.
much, sir.